learning outcomes for this video lesson state that a structure formula is an unambiguous description of the way the atoms in a molecule are arranged, including CH2 double bond CH2, CH3 CH2OH, CH3 COOCH3. Draw and interpret the displayed formula of a molecule to show all the atoms and all the bonds. Write and interpret general formula of the compounds in the same homologous series limited to alkanes CnH2n plus 2, alkenes CnH2n, alcohols CnH2n plus 1 OH, carboxylic acids CnH2n plus 1 COOH. A structure formula displays the atoms of the molecule in the order they are bonding. Now the structure formula, they are showing the order of the arrangement of atoms in a molecule. A structure formula consists of symbols for the atoms connected by short lines that represent chemical bonds like single covalent bonds, double covalent bonds, or triple covalent bonds. But here we are going to show only double covalent bonds. Here an example. If you look at the learning outcome, you can see the example. You have CH2 double bond CH2. This is structure formula of the compound ethene. Now second one, CH3 CH2OH. This is the structure formula of alcohol ethanol. In both of these, you see that only double bond is shown. In ethanol, there's no double bond. That's why I'm just straight away drawing the structure formula. Third example is of ester, which is CH3 COO CH3. This is an ester. The name of this ester is methyl ethanoate. The displayed formula is the one in which we use to show all the bonds between each atom. A dashed line represents the bond between atoms. For example, methane. Recall the molecular formula of methane. This is CH4. We have only one carbon atom. So I am going to show the carbon atom in the middle. And we have 4 hydrogen atoms bonded to this. One, two, three, 4. You see the dash line? These dash lines represent the bond between each atoms. Let's have some more examples of this displayed formula. For example, I want to draw the displayed formula of ethene. The molecular formula of ethene is C2H4. And I've just drawn the structure formula of ethene, which is CH2 double bond CH2. Now I'm going to draw the displayed formula of ethene. So I will draw like this: C double bond C, 1, 2, 3, 4. There are 4 hydrogen atoms bonded to 2 carbon atoms. Each carbon is bonded to 2 hydrogen atoms in this. So there are other examples also. We will see. Recall the general formula of alkanes, which is CnH2n plus 2. You can easily predict the molecular formula of alkanes using this general formula. What you have to do, just place the value of n here. For example, if n is 1, the formula will be C1. Don't need to write 1. 2 multiplied by 1 is 2. 2 plus 2 gives H4. CH4 will be the formula for the first member of alkanes, which is methane. Now, if you want to see more videos related to this, you can simply follow the video link shown below. Alkenes. The general formula for alkenes is CnH2n. First member starts with N2, not N1. The reason is that alkenes must have carbon-carbon double bond. Must have carbon-carbon double bond. There must be at least one carbon-carbon double bond. So the first member starts from N2. So molecular formula will be C2H4. The name is ethene. You can easily predict the molecular formula of other alkene members. What you have to do, just remember this CnH2n. Alternatively, you can watch the video using this link, so you'll find more details about this. Write and interpret general formula of compounds in the same homologous series limited to alcohols. Now alcohols, we have CnH2n plus 2. Sorry, Cn we have CnH2n plus 1 OH as a general formula for alcohols. If the value of N is 1, the molecular formula will be C, and 1 multiplied by 2 is 2, 2 plus 1 is 3, H3OH. This is methanol. Second member, if you put 2 for N, what you'll get? You'll get C2, 2 multiplied by 2 is 4, 4 plus 1, 5, H5OH. This is ethanol. In the same way, you can work out the molecular formula of third member. If the value of N is 3, we will get C3, H, 2 multiplied by 3 is 6, 6 plus 1 is 7, H7OH. The name for this alcohol is propanol. Now I want you to work out the molecular formula of fourth and fifth member of alcohols. Now carboxylic acid, the general formula for carboxylic acid is CnH2n plus 1 COOH. Interestingly, the first member starts with the value of N 0. So if you write or take N as 0, you don't have any carbon, first carbon. So for hydrogen, 2 multiplied by 0 is 0, 0 plus 1 is 1. So we have HCOOH. This will be the molecular formula of the first member of carboxylic acid. So molecular formula will be H2C2O2. The name will be as, sorry, the molecular formula will be CH2O2. As there is only one carbon atom, so you write methanoic acid. The name ends on oic acid. What about the second member? Here the value of N is 1. So if you write 1, you'll get C. H2 multiplied by 1 is 2, 2 plus 1 is 3, CH3, COOH. So the molecular formula will be C2H4O2. Here we have total number of 2 carbon atoms. So I will write ethanoic acid. Again, the name ends on oic acid. What about the third member? If you'll take C2, then you have N2, you have C2, 2 multiplied by 2 is 4, 4 plus 1 is 5, C2H5, COOH. So the molecular formula will be C3H6O2. The name will be propanoic acid. Now I want you to work out the molecular formula for the fourth and fifth member of carboxylic acids. What are structural isomers? Structural isomers are compounds that have same molecular formula but different structural formula. Same molecular formula but different structural formula. Now if you look at this, we find different structural isomers of butane. Here we have molecular formula of butane is C4H10. If you draw the structural isomers of this butane, so one formula will be like this: CH3, CH2, CH2, CH3. And if you want to draw the displayed formula of this, it will be like this: 1, 2, 3, 4. Now I'm placing hydrogen atoms. The other isomer will be drawn in such a way that there must be branching in between. This is a straight chain. So the structure formula for the isomer of butane will be like this: CH3, CH, bracket CH3, then bracket closed, CH3. Now the CH3 in bracket, it shows that it must be attached to this carbon. So if you draw the displayed formula of this isomer, it will be like this: 1, 2, 3. Now CH3 is attached to third carbon, so I will draw like this: C. Now I'm placing hydrogen atoms for each carbon. So this will be the second isomer of butane. Now I'm going to draw the isomers of butene. The molecular formula of butene is C4H8. This is according to the general formula of alkene, which is CnH2n. Here N is 4. If you draw the first structure, it will be a straight chain. It will be like this: CH3, CH2, CH, double bond, CH2. You know that there must be carbon-carbon double bond in butene as it is alkene. Now I'm drawing the displayed formula of this alkene: 1, 2, 3, 4. Now you see the double bond between the third and fourth carbon. In fact, we'll start counting from the right hand side, one from this side. The reason is that the double bond is between on this carbon, between these two carbons. Now placing the hydrogen, saturating our carbons: 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4. So the display formula for the butene will be like this. Now the other isomer of this butene will be like this. You can change the position of carbon-carbon double bond. If you want to draw the isomer of butene, you can simply change the position of this double bond. So it will be like this: CH3, CH, double bond, CH, CH3. Now the displayed formula for this will be 1, 2, double bond, C, C. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This is a structural isomer of butene. Alternatively, you can watch these videos for the isomers of alkane and isomers of alkene. What are functional groups? Now, they are atoms. They are group of atoms or atom that are responsible for the chemical characteristic properties of any homologous series. Responsible for chemical properties of a homologous series. I'm giving you some examples. For example, in alcohols, we have one OH. This is the first member of alcohol. Methanol, second member. I'm writing the name. Second member, ethanol. There are 2 carbon atoms in ethanol. If you see, the common thing in both of these is that they both contain same group of atoms, which is OH. These are functional groups. Functional groups. We call it hydroxyl. So the chemical characteristic properties of this alcohol, these alcohols will depend on the presence of this OH. Now, homologous series, the general characteristics of homologous series, they have same functional group. In a homologous series of family, same functional group. For example, in alkenes, carbon, carbon, double bonds. All the members have at least one carbon-carbon double bond. Alcohols, hydroxyl group. And carboxylic acid have carboxyl group. For your convenience, I am drawing these groups. Carbon-carbon double bond will be like this. Hydroxyl will be like this. Carboxyl, C double bond OOH, it will be like this. Now, the homologous series, they have the same general formula, follow same general formula. Alkanes, all alkanes, they follow same general formula, which is CnH2n plus 2. Alkenes, they all follow this general formula. You can easily predict the molecular formula of any member. Alcohols, CnH2n plus 1 OH. So this is one of the characteristics. Now, each member differs by CH2 group. Each successive member differs by CH2 group, or you can even call it 14 units. In the marking key, in the syllabus learning outcome, they are saying CH2 units. So you can even write CH2 units or groups. Now there's a trend. Trend in physical properties. Trend in physical properties means if any property is increasing, it will increase on showing a regular trend. For example, melting point, boiling point increases. Melting point, boiling point increases as carbon chain increases. So this is the trend. Now all the family members, they have same chemical properties. Same chemical properties. Alternatively, you can watch the videos for this homologo series. Saturated compounds, compounds which contain carbon-carbon single bond compounds. Here, in fact, we are talking about only organic compounds. Compounds which contain only carbon single bonds. Unsaturated compounds. Unsaturated compounds, they contains one carbon double bond. So the SLO says in which one or more carbon bonds are not single. When they are saying not single, it means it must be either double or triple covalent bond. Organic compounds in which one or more carbon bonds are not single. Alternatively, you can watch the video for alkenes. You'll find the details there. Name and draw the structural and displayed formula of unbranched alkanes. Alkenes including but-1-ene and but-2-ene. Alcohols including propane 1-ol, propane 2-ol, butane 1-ol, and butane 2-ol. Carboxylic acids. A structural formula displays the atoms of the molecule in the order they are bonded. The displayed formula is the one in which we use to show all the bonds between each atom. A dashed line represents the bond between atoms. I'm going to give you some examples here. Let's have example of ethane. This is the second member of alkane. Molecular formula of ethane is C2H6. Here the value of N is 2. So the structure formula of ethane will be like this: CH3, CH3. You can place dot here in between these two. If you don't want to put a dot, no problem. Now let's draw the displayed formula of ethane. So in the displayed formula, we will show all the bonds between each atoms. We have 2 carbon atoms. So first of all, I'm going to show the bond between these 2 carbon atoms. Now this bond atom will be counted as first bond of the carbon atom, each carbon atom. So on the right hand side, this will be its first bond, second bond, 2, 3, 4. Now the second carbon atom, this will be counted again as first bond, second bond will be 1, 2, 3, 4. Now place hydrogen atom. In this way, you will draw the displayed formula for each member. Name and draw the structural and displayed formula of unbranched alkanes. So if the value of N is 1, the molecular formula of alkane will be CH4. The structure formula will be like this, CH4, not displayed formula. You have to show the bond between each atoms. There are 4 hydrogen atoms and 1 carbon. So you will place carbon in the middle. 1, 2, 3, 4. Now place hydrogen atom. In this way, you will draw the displayed formula of first member of alkane. For the second member, the value of N is 2. The molecular formula will be C2H6. In order to predict the molecular formula, recall the general formula of alkanes, which is CnH2n plus 2. Now, coming back to this ethane, the structure formula of ethane will be CH3. Now, displayed formula, you have to show the bond between each atoms. 1 bond between 2 carbon atoms. This will be counted as first bond. 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. Now placing hydrogen atoms. Formula for more alkanes. Here the value of N is 3. So the molecular formula will be C3H8. Structure formula will be like this. CH3, CH2, CH3. Now for the displayed formula, there are 3 carbon atoms. So first of all, I'm going to draw the displayed formula for these 3 carbon atoms. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now placing hydrogen atoms. In the same way, you will draw the displayed formula for the fourth member, where the value of N is 4. So molecular formula will be C4H. 2 multiplied by 4 gives 8. 8 plus 2, 10. C4H10. Structural formula: CH3, CH2, CH2, CH3. The displayed formula, I have to draw the bond between 4 carbon atoms. First, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now placing hydrogen atoms. So this will be the final displayed formula of butane. Let's continue. Now here I am having alkene. The first member in alkene start with the value of N2. The reason is that there must be carbon-carbon double bond in each alkene. The general formula for alkene is CnH2n. If you will work out the molecular formula, it will be C2H4. Now for the structure formula, we have to show the double bond between 2 carbon atoms. So it will become like this: CH2 double bond CH2. This will be the structure formula for the first member of alkene, which is ethene. Displayed formula. Now first of all, I'm going to draw the carbon atoms showing bonds between these 2. Double bond. Now this double bond will be counted as 2 bonds for each carbon atom. So for the right hand side, 1, 2, 3, 4. Left hand side, 1, 2, 3, 4. Now place hydrogen. So this will be the final displayed formula, first member of alkene, ethene. Now the second member, when the value of N is 3, the formula will be C3H6. Again, follow the general formula. Now in this case, you have to show the carbon-carbon double bond, but it is between any 2 carbon atoms. So the structure formula will become like this: CH3 CH double bond CH2. For this plate formula, I'm showing the bonds between each carbon atom, one, second carbon, and there must be double bond between these two. Now let's saturate the valency of each carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now placing hydrogen atoms. We have hydrogen atoms. The name for this alkene is propene. Now we have alcohols. Recall the general formula of alcohols. It is CnH2n plus 1 OH. The first member starts with the value of N1. The molecular formula will be CH2 multiplied by 1 is 2, 2 plus 1 is 3, OH. So we have CH3OH. Structural formula. The structural formula of the first member will remain like this: CH3OH. Displayed formula. Here we have only one carbon atom and it is bonded to 3 hydrogen atoms as well as 1 oxygen atom. So the displayed formula will be like this: place carbon first. 1, 2, 3, 4. 4 bonds for carbon atoms. What about oxygen? Oxygen form 2 bonds, 1 bond with carbon atom. Here we will place oxygen, and one of the bond of oxygen will be shared with the hydrogen atom. What about other hydrogen atoms? 1, 2, 3. So this is the formula of first member of alcohol, which is methanol. In the same way, you can draw the structural and displayed formula of other unbranched alcohols. They are saying include propane 1-ol, propane 2-ol. So I'm going to draw the structural and displayed formula of propane 1-ol and propane 2-ol. Propane is the third member of alcohol. So the value of N will be 3 here. Molecular formula for propane 1-ol or propane 2-ol, you can say C3H2 multiplied by 3 is 6, 6 plus 1 is 7, C3H7OH. Structural formula for this alcohol will be CH3, CH2, CH2OH. Now they are saying propane 1-ol. Now 1-ol means the position of OH is on carbon number 1. OH is a functional group in alcohols and it should be placed at position number 1. So first of all, I'm going to show the 3 carbon atoms along with their bonds. 1, 2, 3. Now it's up to you whether you want to place this OH group on the right hand side or on the left hand side, but you can't place that OH in the middle, because if you place it in the middle, you will get propane 2-ol. So I'm placing on right hand side. OH, or you can even write O bond H like this. O bond H. Now let's placing the other hydrogen atoms on each carbon atom. This is the displayed formula of propane 1-ol. So what about the molecular formula, structural formula, and displayed formula for propane 2-ol? It's very simple. Value of N, molecular formula will remain same, but structure formula will be differed because here OH is placed at carbon number 2. At carbon number 2 and should be in the middle. So Here you will draw the structure formula like this: CH3, CH. Now OH is in the middle, so you have to put bracket OH like this, bracket close, then you have CH3. What about the displayed formula? 3 carbon atoms, show bonding between 3 carbon atoms, 1, 2, 3. OH is placed in the middle, so I will write OH in the middle, and other carbon atoms contain hydrogen only. One more hydrogen atom which is attached to the middle carbon. The name will be propane 2-ol. Now this time they are saying structural and displayed formula of butane 1-ol and butane 2-ol. The N will be 4 here. So the molecular formula will be C4H9OH. C4H9OH. Structural formula for butane 1-ol. OH is attached at carbon number 1. So the structure formula will be like this: CH3, CH2, CH2, CH2OH. Showing the displayed formula for this butane -1-ol. 4 carbon atoms, 1, 2, 3, 4. OH is placed on carbon number 1, so it will be like this: O bond H. Now placing hydrogen atoms to each carbon atoms. So this is the displayed formula for butane 1-ol. What about butane 2-ol? It's very simple. Simply change the position of OH. This time it is on carbon number 2. So on the right hand side, I am counting 1. So the carbon atom 2 will contain OH. So the structure formula become like this: CH2, CH3, sorry, CH2. Now you have CHOH. Again, you have to place OH in bracket, bracket closed, and CH3. Now displayed formula: 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Carbon number 2 contains OH, so I will place OH with this carbon. Now placing hydrogen atoms on each carbon atoms. So this will be the final displayed formula for butane 2-ol. Name and draw the structure and displayed formula of carboxylic acids. The carboxylic acid, the first member starts with the value of N as 0. We don't have 1 here because the general formula for carboxylic acid is CnH2n plus 1 COOH. So if you take 0 as N, so first carbon will be omitted automatically. For hydrogen, 2 multiplied by 0 is 0, plus 1 gives 1. So the final molecular formula will be H2CO2 or CH2O2. Structure formula for this one will be HCOOH. It will be like this. What about the displayed formula? Carboxylic acid contains functional group COOH. So you must have C double bond OH in each carboxylic acid. This becomes simple for you, as you have to place only 1 hydrogen atom which is left. This will be the first member of carboxylic acid, and as it contains only 1 carbon atom, so we'll call it methanoic acid. The name of carboxylic acids end on methanoic acid. Second member, the value of N is 1. If you place N1 for carbon, you'll get C. H2 multiplied by 1 is 2, 2 plus 1 is 3. So we'll get CH3 COOH, or it becomes C2 H4O2. So the structure formula will be like this: CH3, COOH or CO2H also. Display formula, first of all, draw the carboxyl group. C double bond O, O bond H. Now we are left with only one CH3, so I will place it on the left hand side. This carbon is bonded to 3 hydrogen atoms. 1, 2, 3. Its name is ethanoic acid. In the same way, you can draw the molecular formula, structure formula, and displayed formula for carboxylic acids with the value of N as 2 and 3. For your convenience, I am just writing their names. In case of 2, you will get propanoic acid. In case of N3, you will get butanoic acid. Remember, count the total carbon atoms. Now, the learning outcomes says state the type of compound present given the chemical name ending in ane, ene, all, or oic acid, or from a molecular, structural, or displayed formula. Name and draw the displayed formula of the unbranched esters, which can be made from unbranched alcohols and carboxylic acids, each containing up to 4 carbon atoms. Now, for the value of N1, in case of alkanes, the name will end on ane. In case of alkene, the name should end on ene, but we don't have any alkene with the value of N1. The reason is that there must be carbon-carbon double bond in case of alkenes. For alcohols, the name will end on all. In case of carboxylic acid, the name will end on oic acid. So the first member in alkane is methane. So I will write methane. This will be the first member. What about alcohol? The name should be methanol. So you write methanol. In case of carboxylic acid, it should be methanoic acid. Methanoic acid. What about the alkanes with the value of N2? The name will be ethane. For alkenes, you will simply make it ethene. Alcohol, ethanol, carboxylic acid, ethanoic acid. Can you predict the molecular formula of, can you predict the names of alkenes with the value of N2, N3 and N4? I want you to predict the names of alkanes, alkenes, alcohols, and carboxylic acids. Carboxylic acid should be butanoic acid. Okay, name and draw the displayed formula of the unbranched esters, which can be made from unbranched alcohols and carboxylic acid, each containing up to 4 carbon atoms. So we have 4 carbon atoms. It means the ester must contain 4 carbon atoms in all. So you can start with methanol and propanoic acid. Methanol and propanoic acid. The displayed formula of methanol will be like this: C bond O bond H. For propanoic acid, there must be 3 carbon. So you must have, you have to add 1 carboxyl group. It's a carboxylic acid. So it will become like this. Now remember, whenever you are making ester from carboxylic acid and alcohol, what you have to do? Simply omit OH from the carboxyl group and OH from alcohol group. What you will get? You will get methyl propanoate. Methyl propanoate. So it will become like this. I am writing propanoate first. 1, 2, 3. Double bond O, O, placing hydrogen for propanoate. Now methyl group, that is coming from alcohol. So the carbon will be bonded to this oxygen. Will become like this. Next alcohol, you can take ethanol and ethanoic acid. Remember, you have to take 4 carbon atoms in all. 1, 2, 3, 4. So you can take ethanol and ethanoic acid. Ethanol and ethanoic acid. In ethanol, you have 2 carbon atoms. The formula will be, displayed formula for ethanol will be like this. For ethanoic acid, remember carboxyl group. So I am drawing first of all carboxyl group, COH, and methyl group here. So it's an ethanoic acid. Simply remove OH in from alcohol and H from carboxylic acid. So you'll get what? You'll get ethyl ethanoate. Ethyl ethanoate. The formula will be, first of all, I'm drawing ethanoate. C double bond O, O. It is bonded to ethyl coming from ethanol. C bond C, placing hydrogen atoms. Now work out the third ester, which can be made from alcohol, propanol, and carboxylic acid, methanoic acid. For your convenience, I am writing the name of the product. You will get propyl methanoate. Propyl methanoate.